Here's part 3 of the screencast covering life in the universe. Let's say that there is an alien technological civilization that is advanced. How long would it take such a civilization to colonize the galaxy? Well, let's use humanity as an example. Let's say that humanity is able to continue as it has been doing since 1687 with the publication of Principia. That is, we have been advancing technologically at an exponential rate. If we assume that humanity continues to expand at this rate out ad infinitum, how long would it take humanity, for example, to colonize the galaxy? Well, we are rapidly exhausting the resources of our planet right now. At the very least, we're going to have to move on to the solar system very soon in order to be able to continue to expand at the rate that we've been doing. So presumably after a few centuries, we will have thoroughly colonized our solar system. Eventually, however, we will begin to exhaust the resources of the entire solar system. At that point, we're going to have to expand outwards even further, that is, out to the nearby stars and so on and so on. So if you make reasonable assumptions about humanity's rate of technological expansion, how long would it take humanity to colonize the entire Milky Way galaxy and become perhaps a Type 3 civilization? If you work out the math, it's somewhere in the neighborhood of a few million years. That sounds like an extremely long period of time, but the Milky Way galaxy and the universe as a whole is about 14 billion years old. That's a considerably longer period of time than just a few million years. So then therefore the question is this: if a technological civilization could colonize a galaxy within a few million years, why hasn't it already been done? Not only that, why hasn't it already been done many times over? When we look out into the universe, when we look out into the galaxy, it appears to be pristine. We see no evidence whatsoever that an alien technological civilization is out there and is advanced to this sort of status. There's a paradox here. In other words, once again, if you make reasonable assumptions about humanity, it should take us just a few million years to colonize the galaxy. So why hasn't it already been done? What is the solution to this paradox? Okay, now with respect to actually getting out to the nearby stars, here's how we might be able to do it. These are a couple of different engineering ideas. The first idea I want to mention here is called Project Starshot. Project Starshot hypothesizes building what is called a light sail. A light sail is basically a very light, thin sheet of foil, and you then use the momentum of light to propel it. Basically, you propel a light sail by focusing laser light upon the sail itself. At our current rate of technology, we actually should be able to build such a ship, such as this, a light sail, and then propel it out to the nearby stars with a top speed of perhaps 20% the speed of light. That places the nearby stars within reach of just a couple of decades. So sometime during mid-century, this engineering idea could come to fruition, where we might be able to send a light sail with a camera attached to it or something like that out to Alpha Centauri. Alpha Centauri is the nearest star system to us. It's about 4.3 light years away. It's a triple star system. The closest member of that star system is called Proxima Centauri. Proxima Centauri has at least 2 planets in orbit around it. So Project Starshot basically aims to send a light sail out to Alpha Centauri by the time, or rather by maybe the end of this century, and photograph the planets that are there. Okay, what about actually sending people out to the nearby stars? That would be considerably more difficult to do because of the amount of energy involved. Back in the 1960s, this idea emerged from an engineering project. This idea is called Project Daedalus. Project Daedalus basically involves building a large starship and then using nuclear propulsion to get it up to perhaps a speed of a few percent the speed of light, and it does place the nearby stars within reach. However, because of the relatively slow speed of just a few percent of the speed of light, it would take centuries to reach the nearby stars. So if we were going to do something like this with people, it would have to be what is referred to as a generation starship. Quite frankly, an idea such as this is probably not feasible. How might we then therefore colonize the Milky Way galaxy if actually sending people out into the universe just proves to be impractical? Well, we might be able to do the following. We might be able to build what are referred to as von Neumann probes. Von Neumann probes is just an idea using nanotechnology to build self-replicating machines. And then what we could do, for example, is transport our genetic material with those machines out to the nearby stars. And then what those machines may be able to do is use the resources of a planetary system out at the nearby stars to then build the infrastructure that is necessary for technological civilization, clone human bodies, and so on and so forth. We might be able to digitize our consciousnesses and send those along with the von Neumann probes as well. Quite frankly, colonizing the galaxy using this as an idea from an energy standpoint is probably much more feasible than doing it by using a generation starship of immense size. Once again, however, we have the problem of the Fermi paradox. Why hasn't this been done already many times over, resulting in a Type 3 civilization, for example, existing within the Milky Way? Well, there are a few ideas as to perhaps why this hasn't happened yet. One idea is called the Great Filter. The Great Filter is basically something that happens that prevents a life form from evolving to a point where it can actually colonize the galaxy. So imagine the Great Filter in the following way. The first hurdle to get over, of course, is life actually evolving on a planet. And then the next hurdle, for example, to get over for that planet would be an intelligent form of life to evolve. And then the next hurdle would be that intelligent form of life being able to build a civilization, build the technology that is necessary to colonize the stars, and so on, and ultimately make it out into the Milky Way galaxy and become a Type 3 civilization. However, something happens along the way that prevents that from happening. Whatever it is that prevents this from happening is referred to as the Great Filter. So the question for humanity then therefore becomes the following. Are we already past the Great Filter? In other words, have we advanced to a point where evolving into a Type 3 technological civilization is an eventuality? Or is the Great Filter ahead of us? In other words, are we eventually going to encounter something, some event or some occurrence that prevents us from colonizing the galaxy and becoming a Type 3 civilization? So where do you think the Great Filter is? Are we already past it, or is it still yet to come? Quite frankly, I tend to think of the latter. All right, so what might the Great Filter be? Well, it's entirely possible that civilizations very simply just destroy themselves. Strong and likely possibility is nuclear war, surviving climate change, and even the information age may lead to societal collapse. So we kind of see signs around us right now of that actually happening. Right now, quite frankly, I think that we are beginning to live through what is called a smartphone dystopia. Then there's also what is called the Grey Goo scenario as a possibility. So remember the nanotechnology I mentioned a few minutes ago about von Neumann probes. Imagine those von Neumann probes, however, running amok and basically then reducing everything around it into what is just their constituent atoms or molecules, what is sometimes referred to somewhat humorously as a gray goo. This particular photograph right here is a still photograph from a film. The film is the remake of The Day the Earth Stood Still. It actually depicts in the film a gray goo scenario. So imagine building these von Neumann machines, and we're going to have them transform our civilization. We're going to send them out to the nearby stars or something like that, as I mentioned earlier, and they kind of get out of control. And as they get out of control, they basically reduce our entire civilization into its constituent atoms and molecules, the gray goo. That's one possibility. Another possibility is particle physics gone awry. Could the Large Hadron Collider, for example, destroy the Earth in some sort of bizarre accident that is within the realm of possibility as allowed by the laws of quantum mechanics? Perhaps this has happened to an alien civilization, for example, that has prevented it from colonizing the Milky Way galaxy. Then, of course, there is what is called the zoo hypothesis. The zoo hypothesis is for all of you UFO enthusiasts. The zoo hypothesis basically hypothesizes the following. It says that yes, there is an advanced technology or technological civilization out there, and they are merely hiding themselves from us because we are a bunch of warlike barbarians. And now, despite our popular culture, there is actually no physical evidence that we have ever been visited by aliens. The zoo hypothesis is an interesting idea, but it is actually untestable. Another possibility is sometimes referred to as death from above. This is kind of like a version of the gray goo scenario. Could there be a machine civilization out there, the remnants of an advanced technological civilization that is actually bent on destroying all organic life? This idea has been explored extensively in science fiction. For example, there is a particular episode of the classic Star Trek series from the 1960s called The Doomsday Machine. This is a photograph from that episode that depicts this as a possible scenario. So maybe there's an advanced machine civilization out there in the Milky Way galaxy that's destroying all organic life before it actually has a chance to colonize the galaxy itself. Okay, let me go ahead and pause this here as part 3 of this screencast.